Hello, calculus fans. Okay, so let's compute some derivatives of some functions. And notice that in everything that we're about to do, we're not going to compute any limits. So we're going to put the limits aside for a while and just start using some shortcut rules that we'll develop. We spent a long time computing limits and computing derivatives using limits. Now that may give you a sense of appreciation for just how powerful these rules that we're going to come up with really are. So let's compute the derivatives of these functions. F of x equals x to the 74, g of t equals t to the 5, and h of z equals z to the 1000. This is actually not a very difficult problem. We can just use the power rule. So remember that the power rule said that the derivative of x to the n was equal to n times x to the n minus 1. So you bring that exponent down in front, and then you change the exponent to be one smaller. Now this was good for positive integers, is what we had said. Now as it turns out, you can actually use the power rule for negative exponents, and we'll prove that later on. The really great part is that the exponent actually doesn't even have to be an integer. The power rule works for any real number, and this is also something that we're going to prove later on. So let's restate the power rule, and we'll just call it now the general power rule, although I'm not really going to call it that. I'm just going to call it the power rule. So the general power rule just says that if n is any real number, it does not actually have to be a positive integer, then the derivative of x to the n is equal to n times x to the n minus 1. So now let's use this general power rule to compute a few more derivatives. So let's try these guys. We'll differentiate 1 over x to the 5, and then we'll also differentiate the fifth root of x squared. So the way to do this is to rewrite f of x as x to the minus 5, and then we can go ahead and use the power rule. So the power rule tells us to bring that exponent down in front, so the exponent is negative 5, and then we have to subtract 1 from the exponent. So when we subtract 1, we're saying negative 5 minus 1, and that's how we get a negative 6 for our new exponent. Now let's try this for g of x. We'll rewrite the fifth root as a 1/5 power. Those are the same thing. And then here, when you have a power on top of a power, you can just multiply those. So you just do 2 multiplied by 1/5 to get x to the 2/5. Now that's something that we can use the power rule on. So now if we want to differentiate x to the 2/5, so we'll bring that 2/5 down in front and subtract 1 from the power. So you'll notice that that shows up here. That power is 2/5 minus 1, and that turns into negative 3/5. So this is our answer. Now we can actually think of the power rule in words by saying, let's just bring the power down in front and subtract 1 from the power. So that's exactly what this thing here is expressing. So anytime you want to take a derivative, you bring the power down in front and subtract 1 from the power. That's all for now.